Managing a restaurant is a logistical nightmare. You have the front of house, the kitchen, the floor, and finance, all operating in silos. Miscommunication between these areas leads to double-booked tables, cold food, and unhappy customers. Current software solutions are just static databases. They record data, but they don't act on it. The problem isn't just storing information, it's coordinating the complex, real-time state changes that happen during a dining service. We needed a system that understands the flow of service, not just the numbers. Why did we use AI agents? Because a restaurant is a team sport. A single, monolithic chatbot cannot handle the nuance of a chef cooking a steak while a captain greets a new guest. By using a multi-agent system, we achieved separation of concerns. We created specialized agents that mimic real-world roles. The captain manages capacity, the waiter manages hospitality, and the chef manages production. These agents maintain their own unique context but communicate via structured handoffs, allowing for a complex, nonlinear workflow that traditional code simply can't handle efficiently. Our architecture is built on the Google Agent Development Kit. At the top, we have an orchestration layer that routes tasks based on the current state of the customer. The system is powered by 14 distinct tools connected via a FastMCP Backend. This allows agents to perform real actions, like checking a database for reservations or calculating tax. Crucially, we implemented callback enforcement mechanisms. This ensures strict protocols are followed. For example, the system physically prevents the waiter from greeting a guest until it has successfully retrieved their order history from the database. Let's see the squad in action. The captain identifies customer John via a phone lookup tool and confirms his 7 p.m. reservation automatically. The captain assigns table 5 and executes a state transfer to the waiter agent. The waiter pulls John's history, recommends the ribeye he loves, and logs the order. The chef receives the data instantly in the kitchen, updating the status to cooking, then ready. The server handles the logistics, delivering the food and updating the state to served. Finally, the cashier generates an itemized bill in the background and the waiter processes the payment, releasing the table back to the inventory. We built Restaurant Squad using Python, Google ADK, Agent Development Kit, Gemini 2.5 Flashlight, FastMCP, Uvicorn, PyTest, and UV. The backend utilizes FastMCP with JSON file-based storage to serve 14 tools over JSON-RPC, while structured prompt engineering gives each agent a distinct personality and ensures strict JSON outputs for database integrity. Restaurant Squad proves that when you combine specialized AI agents with robust tool use, you don't just simulate a restaurant, you optimize it.